The 125% rule for lighting load calculations is a crucial aspect of electrical design. It ensures that branch circuits and overcurrent protection are adequately sized to handle the continuous nature of lighting loads, which contributes to electrical safety and reliability. Let's delve into the specifics of this rule and its implications based on various electrical codes and standards. Firstly, the National Electrical Code, or NEC, Section 210.19. A1 states that lighting load shall be calculated at 125% of the connected load. This requirement is not just a suggestion, but a mandatory provision to prevent overloading and potential fire hazards. The rationale behind this lies in the understanding that lighting systems often operate for extended periods, and their loads can fluctuate. By calculating the load at 125%, designers account for these variations and future load increases. Secondly, the International Electrical Code, or IEEE, specifically IEC 60364-5-523.8, also emphasizes the need to calculate the design load for lighting at 125% of the connected load. This underscores the global recognition of this safety measure in electrical installations. It is essential to remember that these codes aim to protect electrical systems from thermal overload and ensure efficient energy use. Thirdly, the International Building Code, or IEEE, in Section 302.53, reinforces the same principle. The IBC requires that lighting loads be calculated at 125% of the connected load, further solidifying the importance of this factor in building design and safety. The IBC integrates electrical safety standards into overall building codes, ensuring comprehensive safety measures. Fourthly, the Uniform Building Code, or UBC, Section 3003.4.1.2, similarly mandates that lighting loads be calculated at 125% of the connected load. While the UBC is less prevalent now than the IBC, it is still referenced in some jurisdictions and serves as another example of the broad acceptance of this rule. Fifthly, the National Fire Protection Association, or NFPA through NFPA 70, which is also known as the National Electrical Code, Section 210.19. A1 reiterates that lighting loads must be calculated at 125% of the connected load. The NFPA's alignment with this rule is critical, as it plays a pivotal role in promoting fire safety through sound electrical practices. Sixthly, the Institute of Electrical and Electronics Engineers, or IEEE, in IEEE 141, which provides recommended practices for electrical power distribution in industrial plants, also specifies in Section 9.5 that lighting loads should be calculated at 125% of the connected load. This recommendation extends to industrial settings, where lighting demands can be substantial and continuous. Here are some additional notes to consider when applying the 125% demand factor for lighting loads. The 125% demand factor for lighting loads is not arbitrary. It reflects industry-wide acknowledgement of several factors, including the inherent variability in lighting usage and the potential for future load expansion. This approach provides a safety margin to prevent overloading circuits and causing premature equipment failure. Always check with local authorities. Local jurisdictions frequently have specific requirements or amendments to the NEC. Before designing any lighting system, it is crucial to consult with local authorities to ensure full compliance with all applicable codes and regulations. This step prevents costly errors and ensures a safe and code-compliant installation. The specific NEC edition adopted by a jurisdiction can influence the specific requirement. For example, the 2017 NEC might have slightly different wording or interpretations compared to earlier or later editions. Always refer to the specific edition adopted by the local jurisdiction. Consider the type of lighting. While the 125% rule generally applies to continuous lighting loads, it is also essential to consider the specific type of lighting being used. For example, LED lighting is more energy efficient than traditional incandescent or fluorescent lighting, which might influence the overall load calculation and system design. Lighting control systems such as dimmers and occupancy sensors can affect actual lighting loads. However, The initial calculations must still adhere to the 125% rule based on the connected load before applying any reductions due to control systems. Document all calculations and assumptions. When submitting plans for permitting, detailed documentation of all lighting load calculations and assumptions is essential. This documentation should include the connected load, the applied 125% demand factor, and any additional factors considered. Overcurrent protection devices must be rated to handle the increased load calculated using the 125% demand factor. This means that the circuit breakers or fuses protecting the lighting circuits must have an amperage rating sufficient to handle 125% of the connected load. Voltage drop can become more significant when dealing with continuous loads and the 125% demand factor. Ensure that conductors are adequately sized to minimize voltage drop and maintain proper lighting performance. Conductors must be sized to carry the increased current calculated with the 125% demand factor. Refer to NEC Table 310.15. B16 for allowable ampacities of insulated conductors. Emergency lighting systems often have specific requirements. While the 125% rule might still apply to the connected load, additional regulations might govern the design and installation of emergency lighting to ensure reliable operation during power outages. Understand the definition of continuous load. The NEC defines a continuous load as a load where the maximum current is expected to continue for 3 hours or more. Because lighting systems often operate continuously for extended periods, they are generally classified as continuous loads. Consider future load growth. When designing lighting systems, account for potential future load growth. The 125% demand factor helps accommodate this, but also consider whether additional capacity should be included to support future expansions or changes in lighting needs. Periodically review and update lighting load calculations, especially when making changes to the lighting system or building. This ensures that the electrical system remains safe and compliant with current codes and standards. Conduct a load analysis. A thorough load analysis helps determine the actual lighting load and identify any potential issues or inefficiencies. This analysis should include measuring the current draw of the lighting system under various operating conditions. Harmonics generated by certain types of lighting, such as LED lighting with nonlinear power supplies, can affect the electrical system. Consider the impact of harmonics and implement mitigation measures if necessary. Power factor correction can improve the efficiency of the electrical system and reduce energy costs. This is particularly important in large installations with significant lighting loads. Energy efficiency is a key consideration in modern lighting design. Use energy-efficient lighting technologies and control systems to minimize energy consumption and reduce the overall load on the electrical system. Proper grounding is essential for safety and performance. Ensure that the lighting system is properly grounded to prevent electrical shock hazards and minimize electromagnetic interference. Proper ventilation is necessary to prevent overheating of lighting fixtures and control gear. Ensure that lighting fixtures are installed in well-ventilated areas or use fixtures designed for high-temperature environments. Regularly inspect and maintain lighting systems to identify and correct any issues before they become major problems. This includes checking for loose connections, damaged wiring, and malfunctioning components. Use appropriate wiring methods for the lighting system. This might include conduit, cable trays, or other approved wiring methods depending on the application and local codes. Use appropriate electrical boxes and enclosures for lighting fixtures and control gear. These boxes and enclosures must be properly sized and rated for the application. Label all lighting circuits and control panels clearly and accurately. This helps with troubleshooting and maintenance. Provide adequate access to lighting fixtures and control gear for maintenance and repairs. This might include access panels, walkways, or other means of access. Consider the ambient temperature when selecting lighting fixtures and control gear. High ambient temperatures can reduce the lifespan and performance of electrical components. Use lighting control systems to reduce energy consumption and improve the functionality of the lighting system. This might include dimmers, occupancy sensors, or daylight harvesting systems. Consider the color rendering index, or CRI, of the lighting fixtures. CRI measures the ability of a light source to accurately reproduce the colors of objects. Use lighting fixtures with a CRI appropriate for the application. Consider the correlated color temperature, or CCT, of the lighting fixtures. CCT measures the color appearance of the light, ranging from warm to cool. Use lighting fixtures with a CCT appropriate for the application. Design a lighting system to minimize glare and reflections. This can improve visibility and reduce eye strain. Consider the use of task lighting to provide localized illumination for specific tasks. This can reduce the overall lighting load and improve energy efficiency. Consider the use of daylighting to reduce the need for artificial lighting. Daylighting can provide natural illumination and reduce energy consumption. Integrate the lighting system with other building systems, such as HVAC and building automation systems. This can improve overall building performance and energy efficiency. Ensure that the lighting system complies with all applicable codes and standards, including energy codes and accessibility standards. Obtain all necessary permits and inspections for the lighting system. This ensures that the system is installed safely and in compliance with all applicable regulations. Keep accurate records of all lighting system design, installation, and maintenance activities. This can help with troubleshooting and future modifications. Provide training to building occupants on how to operate and maintain the lighting system. This can improve energy efficiency and extend the lifespan of the system. Stay up to date on the latest lighting technologies and trends. This can help you design and install more efficient and effective lighting systems. Always consult with qualified electrical professionals for the design, installation, and maintenance of lighting systems. This ensures that the system is safe, compliant, and performs as intended. The 125% rule for lighting loads is a fundamental principle in electrical engineering. By adhering to this requirement and related guidelines, electrical designers and installers contribute to creating safe, efficient, and reliable electrical systems.